is 21-4. A survey conducted by the Gallup Organization in 1999 asked American adults whether they were satisfied with their physical attractiveness or wish they could be more attractive. The survey revealed that 71% of the women and 81% of the men said that they were satisfied with their appearance. All right, so it asks what additional information is necessary to calculate the p-value and determine whether a significantly different proportion of men than women are satisfied with their appearance. So what we need is we need the sample size. So we need n for each. B, describe a circumstance related to the missing information in which these sample proportions, so 71% and 81%, would not convince you at all that the two genders differ with regard to satisfaction with their appearance. So, if n was small for each sample. So if n is small for each sample, we wouldn't be able to detect that statistically significant difference between the 71% and 81%. So though 10% seems like a big difference, right? If we had a small sample size, we wouldn't be able to find statistical significance. We'd have that p-value that's a little bit too large. C is just the converse of that. Describe a circumstance in which these sample proportions would strongly convince you that the two genders differ with regard to satisfaction of their appearance if n was large for each sample. All right, so D, I created the chart up there. It says use your calculator to determine the test statistic and p-value of the appropriate significant test for the different sample sizes listed in this table. Also record whether the difference in sample proportions is statistically significant at the 10%, 5%, and 1% level. All right, so we're going to run a two-proportion z-test for our null hypothesis. I'll put right up here that pi men equals pi women, and our alternative pi men does not equal. So we're going to do a two-sided alternative hypothesis. Right? So in our calculator, using our two-prop z-test, what we're doing here is holding that 71% and 81% constant while increasing the sample size from 100 to 200 to 500 to see what the effective sample size has on us being able to detect statistical significance. So for this one, I got z is negative 1.66, p-value of 0.098. We would find statistical significance at the 10%, but we would not at the 5% and the 1% significance level. And then with a sample size of 200, I get to test this statistic of negative 2.36 and p-value of 0.019. We find significance here, but not at the 1% significance level. And then for our sample size of 500, test statistic of negative 3.73 and a p-value of approximately 0. And we find significance at all three levels. So what do we notice as sample size increases? It's easier to detect that difference of 10% between the two population proportions. When he says to write a sentence or two commenting on the role of sample size in determining whether a difference between two sample proportions is statistically significant. And as this book typically does, which is somewhat irritating, the answer immediately follows in E. So it says this activity should reinforce what you learned earlier about the effect of sample size on inference procedures. An observed difference in sample proportions is more statistically significant, unlikely to have occurred by chance alone, with larger sample sizes. So even a small difference can be statistically significant with a large sample size. All right, so 21-5, graduate admissions discrimination. Recall from activity 626 on page 117 that the University of California at Berkeley was alleged to have discriminated against women in its graduate admissions practices in 1973. When you analyze the data from the 6 largest graduate programs, you found that 1,195 of the 2,681 male applicants had been accepted, and that 559 of the 1,835 female applicants had been accepted. So we're going to conduct a complete analysis to see if there is evidence that the true proportion of all males accepted exceeds the true proportion of all females. So let's go through all four steps for this. The 21-5. Let's start by stating our procedure. So get in the habit of doing this. This is a two-proportion z-test. Okay? And we're going to do our null and alternative hypotheses. So we think pi of males equals pi of females, and we want to go ahead and see if we can prove that the proportion of males is greater than the true proportion of females. Okay? We're not given a significance level, so I'm going to choose a 5% significance level, and then define our parameters. So the true proportion of all males accepted into the graduate program at Berkeley. And then pi females, same, but for females. Next, we're going to check conditions. So conditions, a simple random sample for both. And we don't know how they gathered the data. It doesn't appear that it's a simple random sample. 2, no reason to believe the 2 samples are not independent. Now, there's not going to be any overlap in this case, right? Because we have men and women. You can't be both. Okay? And then 3, our p-hat combined. We have 1,195 plus 559 over 2681 plus 1835. Our p-hat combined here that's 1754 over 4516. Or 0.388. We're going to take that, we're going to multiply it by both the sample sizes. So 2681 times 0.388 is greater than or equal to 5. 2681 times 1 minus 0.388 is greater than or equal to 5. And then 1835 times 0.388 is greater than or equal to 5. And then 1835 times 1 minus 0.388 is also greater than 5. So we need to crank each of these out. So we have 1040.2 greater than or equal to 5. Check. Remember, this is to make sure that our central limit theorem can apply. And we got 1640.7 is greater than or equal to 5. And 712 is greater than or equal to 5. And 1123 is greater than or equal to 5, right? So we have a large enough sample size for our central limit theorem to apply, guaranteeing that we have that approximately normal shape so our p-value and our normal calculations can take place. So now it's up to finding our test statistics, and we're going to use our calculator for this, our p-value. And we want to see if we can reject or fail to reject at the 5% significance level. So in the test in our calculator, and we're going to do a 2-prot z-test. And we're going to see if 1195 over 681 greater than 559 over 1835. And I got a z of 9.56 and a p-value of approximately 0. So since 0 is less than 0.05, we're going to reject the null hypothesis. And then our conclusion in context. At the 5% significance level, there is sufficient evidence to say that the true proportion of all women admitted to Berkeley Leeds graduate school is less than the true proportion of men. Right? And remember, we could have switched that around and said the true proportion of men is greater than the true proportion of women. We get the same result then. Remember, if we wanted to figure out the magnitude of the difference, how much that difference is, we could create a confidence interval. So we always want to make sure we go ahead and answer the actual question. We did find statistically significant difference, right? However, can we draw a definitive conclusion? Well, going back to those conclusions, it does not say that the samples were random, right? We don't have a random sample. So there might be something significant about that, different about that year that would preclude us. So though we found significant difference, our conditions weren't met, so we're going to proceed with caution in our final analysis. But let's go up and answer the question. It does appear, based on this test, that there is sufficient evidence that women were discriminated against, right? So on the bottom of the page says, these inference procedures for comparing to proportion can be used with data from observational studies as well as controlled experiments. No matter how statistically significant a difference might be, however, you cannot draw conclusions about causation from an observational study. Right? We can only do that from an experiment. In this case, you do not have random samples from populations either, so the significant test only tells you that the observed difference in acceptance rates between men and women cannot reasonably be explained by random chance. All right?